project that allowed me to be here in this amazing geoarchaeological field school. It was also one of my few times doing a field trip, and this was one of the best, of course, for the people I met and the amount of knowledge I have been able to learn. So I'm going now to present my PhD project, which is also based on geoarchaeology, but it's a slightly different type of geoarchaeology, in particular for its application. And also you will see that we are going to talk about different environments from that we've seen in Tonsanji. And yeah, the title of my project is Human Environmental Interactions and Climate Changes during the Holocene in Sardinia in the Mediterranean Sea. Okay. So during the presentation I will follow basically this outline where I will explain the research questions that drive my research. I will give a brief introduction to bioclimate and environmental research. I will give you the geographical context and you will see the methodology and the approach that I will follow during this project, not conclusion. One thing is, if there is something that is not clear, and because of the presentation or because of my English, so the presentation will be very, very, very quick and short, so there will be time for questions or anything. So here you can see the research question. The main one is how did climate changes impact past societies in the Mediterranean region, which is a quite I would say mainstream today, but the thing here is that, as I said before, I'm going to apply a geoarchaeological integrated approach to answer this main question, but also a comparative study using the Sardinia island. So I will also try to investigate which was the impact of societies on their environment and whether we can disentangle the role of climate changes from that of human impacts, so land use on the bioenvironmental. So, quick introduction to bioclimate research. So, bioclimatology basically deals with the reconstruction of past climate conditions. Among the most important are, of course, temperature and precipitation. But how we can understand something that it doesn't have, didn't leave any evident trace of it. So in bioclimate, researchers use a lot of proxy data. So a proxy is basically measured data of something that can give you an indicator of your investigated variable, which cannot be investigated directly. So, for example, a variable which cannot be investigated directly today are its sea level, but also temperature, past temperatures and precipitation. And for maybe the most mainstream example is the use of oxygen isotopes from biogenic carbonates from deposited in the oceans to retrieve the extent of past glaciers in the North Atlantic region, for example. So bioclimate is based on proxy data and modeling, because the measuring of these indicators alone is always not enough. So there is a lot of modeling in it, and through these two approaches, bioclimate researchers can obtain long-term regional models and also indication of punctual climate changes. So in this graph here, you see that the editors use a lot of proxy data to reach the model, which is basically the red and blue bands that you see on the level. You can barely read probably. So on the right you see that the Holocene climate of the southwestern Mediterranean was characterized from 12,000 years ago to around 6,000 years ago by very dry winters and cooling waters entering into the Mediterranean. While a market change occurred around 5,000 years ago with very wet winters and a flattening cooling. So why this is important, all of this? Because we have to try to understand which were the impacts of these changing climate conditions in the region we are studying. So climate change can be a first mechanism of bioenvironmental change, but bioenvironmental changes can be driven also by humans. And a most intricate one is when climate changes impact human societies and at the same time human societies, and indirectly they impact their environments. One thing to bear in mind is that it's important to have independent proxy data, because when you don't have independent climate data, it's very difficult to understand and to disentangle the roles of climate in humans. For example, in this graph here, you have plotted the 4 main pollen sequences for Sardinia. And the main thing that you can see is how the green line, which represents evergreen oak forests, is almost has almost an opposite trend compared to the brown line, which is shrubland taxa forests. So something occurred in the around 5,000 years ago in Sardinia with a complete replacement of shrubland taxa forests by evergreen oaks. But we don't have climate data, so we can't say very with certainty what happened in Sardinia without having independent climate data. Because one very important thing is that you can rely on the climate data from other regions, even nearby regions, because it's a very complex thing, and a model that is published today is probably going to be updated like in 2 or 3 months. So it's a ever changing field of studies. So this is the geographical context. Sardinia is the second biggest island of Mediterranean, and I've chosen 3 key study areas for their importance as environmental and geoarchaeological archives. Also to have a spatially even distributed case studies to reach a regional scale model. And Sardinia has been very intensively settled since the Neolithic and home of monumental building societies during the Bronze Age, a period that sees lots of monumental building societies spread around the Mediterranean. So here are the methods for my research. At the root of everything there is always fieldwork, which is a thing that we have been able to learn these days, so anchoring and borehole strategy, but sometimes we can't always apply the strategy, especially where there is a lot of bureaucracy to do. So you have to rely on other things, for example, already exposed sequences that you might be able to sample more quickly and in less amount of time and documents to produce. So the samples that you can obtain, you can use them to make think sections for micromorphology analysis to identify human impacts on soils, but also the properties of buried soils that are also very important indicators of the environmental conditions. I will also apply geochemical analysis of the soil and sediments, because as you may understand that we don't have independent climate data in Sardinia. So a very important thing will be to use this geochemical data as a proxy data for the climate conditions. It's very complex because you have to be able to disentangle which are the mechanisms that drive the changes in the geochemical signature of what you are observing. So you have to do a lot of background work to understand local geology and the local source of all the elements that you are studying. And if I be able to do, I'm also keen to do pollen or phytolytic analysis, because they are, of course, very important indicators of the environmental conditions, and merge all these things with scientific programming, Python and R, to test for example, with some statistic correlations, and to draw some model and combine everything with what we know about the paleoclimate of the Mediterranean in the last 8,000 years. And of course, GIS is very important to produce maps that are useful at any step in this process. So the expected outcomes are basically what you have seen these 4 days. Even though I'm trying to do this in 3 years, but I would say that firstly I tried to understand which were the impacts of climate changes in Sardinia, and also to disentangle the role of human versus climate, and to finally reach a comparative study to piece Sardinia in the frame of the paleoclimate research in the Mediterranean, which is a very punctual thing nowadays. Thank you very much for your attention.